Hello and welcome to episode 143 in this series where I'm programming an NES game live on Twitch from scratch. Let's get going. One thing I'm going to mention here is I'm thinking about posting I was kind of laughing at the idea of calling it the TLDR version of the episode. Where I just kind of cut out all the trial and error stuff and just kind of leave in the relevant parts. It might make me cry because it might be like 3 minutes of a hour and a half long episode or something. But just for the sake of, people who don't want to watch the whole process, they just want to see the results. If I could do that and kind of strip out some of that stuff, I think that might be useful for people. But we'll see. We'll see if I feel up to doing that, because editing is very tedious. Even though I do like doing it, it just is a very time-consuming thing. And the longer the stream, the more time it takes to do the editing. So, in the last episode, we got the export process to correctly modify or process the tiled map file, so that where'd my controller go? I rearranged my desk so things got all moved around, so that the export this is that's an old export, but that's okay. We got that working, and then we spent some time building some functionality to pick up what the attribute values should be for the metatiles. And then after going through how we were dealing with the metatiles, I wrote this little note to myself here that we need to do a lookup of what metatile is using, or what attribute should be used for a particular metatile. So the other thing that we're doing in the way that all of this kind of comes together with the map file is we were writing out, we have a .palette file, I believe, that is just a, what is this loading? So this is loading whatever palette files we determine are needed. I don't actually even remember exactly. So these are all the palettes for the different metatiles. Now the obvious problem with doing something like this is we have 8 palettes, but realistically there are only 2 that are in use. If we go to, did I close it? If we go to NES Screen Tool and we load back up the palette we were working with the other day, we only have these 2 palettes. And this color, actually let's make it a non-strange color. So we've got 2 colors here in this one palette and 2 colors here in this other palette. And then the final palettes here are unused. Let's make these all blacked out so that they don't cause any issues. So that's our palette. And so what we really want to do, while we could consolidate and share palette files for the metatiles, I'm almost wondering if that's just overkill, because at most you're talking about 16 bytes for the map, and there might be some additional palettes we load in like we were talking about, and I was thinking about how that would play out and how we would reference those in tiled. But I'm almost wondering if in the object layer, when we create whatever it is we're creating, to identify that we need to do a palette swap, we could include the actual palette colors in there. And that would be pretty cool, because then that would mean that we wouldn't have to worry about any additional files. It would actually be part of the definition of the of the thing, of the identifier, of the trigger in the map, of what the palette is that we're swapping to. So it would say, you know, swap palette number 3 and have the 4 values for the palettes that we would need. So what I'm thinking about doing is instead of writing the palettes like this, what I'm thinking of doing, I'm going to leave this stuff alone. I'm not going to change it because I don't want to mess with that right now. But what I'm thinking about doing is in the map file, we'll write out our 16 colors for the palette that we want to load for the map. And then in load map, one thing I made, I got excited to start coding here, and so I added a change that Metatile attribute lookup is actually now passed as a parameter here, so that it's used when we are populating the attribute lookup array. It's being passed in and used that way, so that we have that available to the export call. So that's important because we need to be able to include that lookup in the map. What probably want to do also is have a, do we care about a count? I guess we probably want to have a count too, just for the sake of not having to recompute it. Because I believe we'll have it here since we're populating it as we go. Is that right? I guess actually we, well, they would be contiguous, so technically we don't, right? We don't. Okay, yeah, actually I take that back. We don't need to do this because we're not populating it in the same way as we might another array where, you know, there might be gaps. This is going to be contiguous. And it's just basically us brute forcing the metatile values into, or the corresponding attributes for the metatiles into this array. So all we would need to do here before we get started is just, you know, if metatile actually I want to do that, right? I want it to be I want to go until we hit the uninitialized value. So, you know, the limit there is then 255, which is okay. I mean, if we hit that limit, then we've got to probably reevaluate a bunch of other things. So I do need this. But we're just going to set it here. Right, so we're basically just looping through. We'll double check this. I'm pretty sure this is right, but we're looping through this array to find one that we haven't set, and then that will tell us our count. Well, this +1 will give us our count. All right. Actually, no, because if we, in the 0 case, if the first one is 0 for some reason, then the count is 0. It's not 1. All right, great. So let's just test this, make sure that this seems correct before we move ahead. So we're at this breakpoint, which I don't care about anymore. Or that one I don't care about. Nope. Okay. Metachile attribute count is 0. No. Why? Because what? Did we zero out all those values? When we went into that function, maybe. I mean, that's kind of the responsible thing to do, but I don't know. I don't recall off the top of my head if we did. I don't want that to be what we did here, but, well, let's see. That's weird. Let's take a look at that. I thought it would set it to 255. Nope, it's just setting the first one. Why? Okay, because it's, I guess, zeroing out the rest of the values. Is that how that works? Okay, that was my misunderstanding of how that worked. I mean, usually... I know I made a mistake. Just give me a second. Usually this is the way I do it anyway. Just with a straight up mem set. But I thought for some reason that initialized all the array elements. But clearly not. Hope everybody is having a good evening. The week started out strong. Can't really complain. So... I'm just glad to be working on this, and hopefully we'll make some good progress tonight and get the map looking like it's supposed to. All right, good. So we've got 5 values now. That's correct. And so what we want to do now is we're going to update the way that we store the data into the map. We're going to add... First, we're going to add, for better or for worse, we're going to add the lookup table data just because we have that already. So let's do that. So that's the... Should probably label these areas, right? Just so it's not like, what does this do again? I don't know. I feel like you might get tired of hearing me to say those things. I'm just adding some comments here so that I know what each section is doing, where it's obvious what it's doing. So here's the map itself. I should clarify. There we go. And then so we've kind of commented out a bunch of this stuff. And so what we're going to do here is I'm going to change. You can always use the viewers as your rubber duck. Yeah, I mean, that's kind of what ends up happening. There are some times where you'll get something like last week where MDTAUK, I always have a hard time saying that. suggest something and he's totally right and it was a good idea, or you get something like where somebody is, you know, already knowledgeable at the NES and they ask questions about different approaches and, you know, have some thoughts and stuff, and it's cool. I like that, but also sometimes me explaining what I'm doing, I'm like, oh no, that is dumb, I should not do that. All right, so because we are lookup count, so these lookups are the lookups for the metatiles, which are contiguous, but that is fine. We're going to leave those alone. For the map palette stuff, what I'm going to do is I'm going to I forget what I called that already. Oh. So we're going to write that. We're going to write the value of that, which is just going to be 1 byte, to the file, which will tell us how many attribute lookups we have available to us. And then we're going to actually write the attribute lookup to the file. And we're going to write as many as we have. And so we got to change the way that the NES code is loading this, but that's fine. And then the last thing I want to change here, and I'm going to hard code this for the sake of testing out this bit of the logic here, and then we'll worry about loading this from the exported palette from Screen Tool. Let's hard code a palette into the file and then go to the assembly side. Come to the assembly side. We'll go to the assembly side and see what's going on with that and what we have to change. So just in case it wouldn't be obvious of any other way. So 0f 1 2 2 2 and 0f, right? So that's our first palette. Actually, I've been using 0e, so let's be consistent here. 0e. Here, let's... Why is it not showing me 0e? Does it not want me to use 0e? Okay, fine. That's weird. But anyway, I don't care. So this one is 0C. This one is 29. That's that, and then we'll do 1 2 3 4, and then get rid of that and that and okay. So those are our 4 palettes hard-coded for the sake of testing purposes. Oh, why didn't you space it out nicely for me, huh? Visual Studio. So that's that, and then we're gonna we're just gonna literally write this out. And this will be our test for the assembly side of things now. So let's export this. Hope things don't crash. And find, I don't know why that's still up. Find a window to where I want it to be. Okay, so export. Let's just delete everything from here just in case, and then run that. Okay, everything exported. Map1, not object. Object. Okay, cool. Let's open this up in Fred. Let's just double check that things here make sense. Always helps to confirm your data before you start trying to work with it, just in case. All right, so we have our map height of 105, and then from there, that's this first right that we do here, and then let's see, the next right we do is our attribute count, which is 5, and then we have that's weird that that's DD, but I feel like that's what it actually was when we were looking at this. Now that oh, and it's, you know why? It's because there is no Metatile 0. Or Metatile 0 is not actually used in the map, because it would then be an empty tile. So let's do this for the sake of sanity. Where's our this? Let's just make that 0. So that'll be palette, palette 1 by default, which is fine. So let's take a look at that. Why is that still 8-0? 8-0? That's 128. Where is that coming from? I don't like that. Do not like that. Why on earth? Okay, so that's got what I expected to have in there, and then it comes out that way. All right, let me go back. Can I? I can't restart. Okay. I wanted to step in, and I didn't. That's okay. Metatile attribute lookup. Yes. Thank you. Okay. So then let's go into here. So Metatile map. Where's my other memory window? There it is. Metatile map. At position 0. Or at I is 0. The value is 1. Is that palette 1? I believe it is not. I believe palette. What is this? Was is this? Oh, well, no. Which one is, what color is that? I don't know. It's the palette, right? Yeah. It must be the red. Okay, because it's blending with the blue and making purple. Okay. Why did I do that? I don't know. I don't think it matters. I don't think it's actually been exported that way in this version that we have here. I think I was demonstrating something. Probably should have been more consistent. No, it is here as well. All right. I'm going to ignore that for now. I don't really care about that so much. So this is metatile 1. So these are the metatiles, and then attribute grid. Okay, attribute grid is showing the 0. Okay, that's fine. So how C. Hey, Arachnarenth, how's it going? Or Archnarenth. I did that last time too. Archnarenth. So what is causing that to mess up? Metatile. There must be a metatile value of 1441 somewhere, or 0. What is? Let's restart again. Where's my breakpoint? There it is. All right, so we have metatile attribute lookup, which was that, and then metatile map, which is that. And that's fine. Those look. That's the metatile. Those metatiles look right. The attribute grid has that one sort of weird thing to it, but that's okay because that's expected. Where would 8C be coming from? Or some value like that. Let's kind of, I wish there was a faster way. You know what we can do? Can we put a watch on this? I think you can do that, right? Surely it's possible. Toggle breakpoint. Can we do a conditional breakpoint here? Condition. Condition is true, and so that's. I can't see my code. Oh, it's right there. Metatile attribute lookup. Actually, let's do it. I can't do it there. Let's see if we can catch it here. Metatile attribute lookup 0 does not equal 0. So that's our condition. And, oh, we hit it. Really? Max map buffer. Hey, Miak, it's going good. Trying to get these palettes finally into the NES side. Just found a weird issue with the way that it's doing a lookup or calculating this tile to attribute lookup. Yeah, so to clarify, the data here on the right is, these are the attribute values, the palette selection values that we are calculating. And then there's this one here. This is the actual, these are the actual tiles that we're plotting on screen. So we're calculating these, and then we're also calculating what palettes they should be using. But we're running into a problem where somehow we're getting some weird bogus values. Let's see. So map buffer I minus 1 is 0. Metatile map I minus 1 is 0. Metatile, let's see. Attribute grid I minus 1 is 253. Why is that? Attribute grid 253. 253 is FD. So what is that? Is that just junk? Is attribute grid not big enough? Attribute grid is defined there, and we allocate it based on the half the width and the height, which is 1681, and the width, well, we're at 1681 right now. It may be that this is not big enough. That is entirely possible. So let's see. So the tile width is that, and the tile height is that. So what we're saying is we want, and we're doing half. So 16 times 105 is 1680. Yeah, so that's not big enough. Why? Oh, is this a problem of... Yeah, I guess it would be a problem of that. We don't really need to go through the whole map buffer. Like we could. Okay. All right. This makes more sense. So it's just corrupted data. Basically, max map buffer. This buffer is huge. It's 8K. I mean, huge is relative, but it's 8K. It's just a large allocation of space. And this metatile attribute lookup is not that big. So we have a couple options. We could make it, attribute grid is not that big. So we have a couple options where we could either make it that big. Do we ever free this? No, we should. So we could either make it that big and waste the space, or we could just only allocate or only loop through the actual number of tiles we need, which is probably better. So what we can do here is make something called adjusted total size. I assume the width and where does the width and height come in? So that's that. We still have to declare this outside so that it's accessible to all. So there we go. We have adjusted total size, and then what we do is we will just loop that many times. We don't have to loop through the entire map because the entire map is too big. Okay, so now if we look at Metatile lookup, hey, attribute lookup, that looks much better. We're not getting any junk values in there, so that's excellent. So we can step out of there. Do we have the breakpoint still for where we are writing? Actually, it doesn't matter, but, or it does matter, but I don't need to see that now. Okay, so now let's reopen the file. And we have 5 and, yep, 0, 0, 0, 1, 1. 5 values. So that's good. That's the count and the lookup. And then we're going to have our palette of 16 bytes. 1, 2, 3, 4. So those are our 4 palette values. Then we have the Sprite palette lookup, which is just hard-coded. Eventually we will fix that as well. Then we have our map lookup, which is, again, hard-coded, but not, I mean, it's hard-coded, but a little bit more flexible than that. These are things we will have to adjust as we go, but finally we get to the actual map data and we write that out and we're good. Okay, so that means this is correct now. See, it's good that I checked. Feel good about this. We go here, we copy our data over, we replace the existing files. Let's go to our assembly code that loads the map. I think that might actually be in, okay, so that's in load level. So now this is used through scrolling and changes. Okay. This is the row count. Modifying the map, this has to change. I guess I should have explained, I mean, I think I know why that is, but I believe that is because, what is that? 0e is 15. Is that the number of bytes that we have preceding something? I don't know. Load level memory and add 15. And level memory is, again, something. This points to the beginning of the level data. Okay, so that's finding the map low position and the high position. I forget what the 15 bytes that it skips are for. And I don't think that will work if we make it variable. Again, not a huge problem. We can fix that. Get out of here. Clicked on the wrong thing. Yeah, this is it's probably 1, 2, 3, 4, 5, 6, 7. Now, it still would have been more bytes than that. I was thinking maybe it was the size of the bytes before we added some of this lookup data, but it seems like it's not, that it's still the same. Let me see here. Or it is not the same. It seems like that's not what it would be. Well, we can step through the assembly and make, and see what we're getting and work our way through there. So that's the max rows, which is the first byte of the map data. And then we get our camera position, right? Okay, and then we want to initialize our palette, and what this is doing is so we'll move this around. Basically, this is just taking a pre-existing palette and loading it into a position in the PPU, and I'm not going to do it this way. Here we can do it slightly differently, where we actually load just the raw values, because we're going to have those values here. So this is the lookup data for the palettes, the attribute values that are needed for the Metatiles. So what we need to do is we need to store that address somewhere for later use. So let's create something for that purpose. Okay, so let's go here. We have level memory and screen memory. Let's call this metatile adder, empty adder lookup. It's our 2 bytes, 2 grapes. All right, so we've got our 2 bytes. Sorry, I don't know why I felt the need to interject that random Simpsons reference for when Marge goes to the store and requests a price check on 2 grapes. And the guy sarcastically announces it over the store loudspeaker. Gonna get a price check on 2 grapes. All right, so yeah, so we have our row memory here. So what we want to do is just load a row mem store A into, what did I call that? Empty adder lookup, empty adder lookup. And then okay, so let's put a comment here. Store the attribute lookup information position in ROM. Although actually, thinking about this, this is pointing now to the number of lookups, not the lookup data itself. So what we probably want to do is we want to load that here and store that into our good friend temp, because we will need that. I don't think we're using temp anywhere in here for anything yet, so that should be safe. We're going to need that to know how much we want to increment row mem. We should probably, really don't want to do it this way, but it's not really what we should be doing. Is actually, I don't remember. Bear with me a second here, because I don't remember how this works. We'll do some quick. This resource, I've mentioned it a bunch of times, but if you haven't seen it before, this is a lovely, lovely page for 6502 programming. So I can't remember if increment will trigger the carry flag. So I can test it here. So incrementing 0, or incrementing address 0, here, and we can, wait a minute. That's load A, that value, store A, 0, increment 0, load A, 0. So just to check, A should be 0 at the end from loading that. So we can, what I'm doing, can you just do increment A? No, okay, I didn't think so. What I was checking was I couldn't remember if incrementing an address causes a carry, if it would normally carry, like, so if you load A with that value and then you clear carry and add carry with 1, you'll see carry flag is not going to be, it will be set to 1 after this, even though it's the same operation. I've used that page a lot. Also similar one back when I was doing 8080 assembly back in college. Oh, that's cool. I didn't know. That would be neat to see. I haven't done 8080 or 8. Yeah, it was 8080 in, actually, maybe it was 8086. But yeah, I haven't done that in a long time. I wrote a really primitive, like, original Mario Brothers clone type game using text output in 8086 assembler. That was that was for a microprocessors class I was taking in college. That was kind of fun. All right, so the whole reason for what I was talking about here was we really should be doing this. Branch carry clear to here. So basically, I don't know if it's better to do. Okay, so basically we're incrementing ROMEM if for some reason we were on a memory boundary where it would carry on the add, the increment. We wouldn't have caught that and we'd have a problem in our code. It hasn't happened yet, but that doesn't mean it won't. So we do an add with carry, and then if the carry is clear afterwards, then we just store ROMEM. Otherwise, we will increment ROMEM plus 1, which is what we need to do, and then store that. All right, so and then we'll do that again here. This is an example of where maybe you'd want something that's you'd want to use a macro for something like this, because you could type this all day. And it would just be better not to have to. So, okay, so now we incremented ROMEM past the lookup count. We store the address in empty attr lookup, and then what we want to do is the same thing except clear carry, add carry temp, branch carry clear, otherwise increment ROMEM plus 1, and then okay. So before we go any further, let's make sure my assembly is good. It is, except I misspelled it here. Okay, so that worked fine. Or the code assembled. I don't know if it worked. I'm pretty sure it worked. to do what we want to do there. Let's go back to the data. So after we've skipped over that, we are now in the palette section of the map. And so what we're going to do is we're just going to do a very basic increment through the map here. Right now, I believe Y is set to 0 as we go through here, because we were using it to address into this memory, and then when we were writing the loops, then we were using it as our index. So, oops. So what we're gonna do is we're gonna set ourselves up to load the palette, and we're gonna do that by me trying to remember how to do that. What the address is. I can't remember the address. I know how to do it, but I can't remember the address. It is 3F00. Okay. So 3F, and then store it into 2006, load 00. The nice thing about this is once we get this set up for an appropriate loop, it's pretty straightforward. We're going to read 2000, clear the palette the PPU latch, right? And then we're going to set the beginning 3F00 as the first location in the palette. And then we're going to do load A, romem Y, store A into 2007. So that's going to write it into the PPU. We're going to increment Y, compare Y to 16, which is that. Branch if not equal to palette loop. So we will stop after we have loaded all 16 palettes into the background memory, and then we should load A. Load A with. I'm having a brain fart here. Yeah, you can do that. Load Y with 0 to reset it, and then we want to increment the romem 16 to skip over that. So load a romem, clear carry, or let me do. Wait a minute. Just thought of something here. Another reason why this is better to have as a macro, because let's see, romem. Yeah, because if you don't do the crucial store, then it does nothing. So the thing that always confuses me is that the increment is it loads it, increments it, and stores it in one opcode, which is really nice. The method of load, clear, add, and then you need the store explicitly, and I didn't do that. Compare Y to. Did I use an address instead of? Yes, thank you. That was a typo. That should be the literal. Yep. All right, so that's get the lookup count. We did that, and then we romem, and then load a romem, store the blah blah, and then we have this, and then yeah, this is where. Okay. Otherwise, we wouldn't have been loading the right palette information here. So we do that, and then we load Y0, and we say, okay, load A, romem, clear carry, add carry, 16, branch of carry clear, increment romem +1, and then we have that label, and then we say store a romem. So we load it, we clear the carry, we add 16. If the carry is clear, we skip this increment. Otherwise, we do it, and then we store romem. Okay, So that's fine now. Let's get rid of this code. That stuff hasn't changed, right? We didn't change the Sprite lookup or the Metatile lookup. So I don't think anything has to change there. So let's see how that goes. We may, this may be a complete disaster, but I feel like this is probably close. Whoa, okay. That's interesting. All right, so we know we're actually loading something into the palette. So that's a good first start. Well, some of the colors look close. Let's take a look at the palette viewer. This first palette, that actually, no, that's not right. It just happened to have one of the colors that I was thinking of at the time, but that's not. Oh, maybe. But the second one is definitely not, and the third and fourth are absolutely not. So let us go to not another PPU viewer. Let's go to our code here. Let's go to load level. And where is our palette loop? Let's see where we are at that point. I assume, well, you know what? Let's go back a little bit further because I want to see where we are with the lookup count. Because the lookup count, if that's wrong, then we know that we've made a mistake somewhere. So here's our breakpoint. Load A with that, and that's 5. Okay, that's good. And we're going to put that into temp, which now has the value of 5. So we're going to load that, clear the carry, add with carry, branch, okay. Store that back into row mem. So row mem is 99 D5. And then store the attribute lookup information position in ROM. So this has no value right now, and this will now match that. Okay. Temp is still 5, so row mem will get incremented by 5. Load A with that, clear, add, that gives us DA, no carry, so we store that, and we get 99 DA. Let's take a look at that memory. Five. 1, 2, 3, 4, 5. That value is actually right. So E gets stored in 2000. That, I mean, that value is right. That is 12. That's correct. Oh, I can see it updating while it's doing it. Cool. All right. So that's that. All of that is right. So far, so good. Oh. Okay. Wait. I think I know what happened. No, because we did that increment. So. Oh, because of the Sprite palette loop. Oh, yeah. Okay. Interesting. I hadn't considered that. So this is expecting... well, but that's... that is... Why did that break my code? Branch of unequal palette loop. That should be okay. That loads the 4, and then I'm not sure why. Let's keep going. this is all looking good so far because all the palettes are, hey, MDTAUK, how's it going? This is loading up the palettes very nicely. You can see it's zeroing out everything the way that we want it to. And then we're going to zero out load Y. We're going to load the row memory, and we're going to add 16 to it. And then there was no carry, so we're going to store it. So let's go back to our memory tools. And so let's see. Row mem is now 99EA, which is that location, which is, that should just be the Sprite lookup, where it just kind of plunks in some palette values now. Oh, why did it change? Why did it change the background sprites? The background palettes, though. That's not right. Load palette. I know there's a way that you tell it what, that it's for a sprite. Param2 is 80. It's doing that here. So, and that, and branch if not equal to load sprite palette. Read the latch. 3F00. Wait. Load a param2 and end it, and then compare it to 8. If that bit is set, then skip palette load. Multiply by 4. Why? We are setting the OR onto parameter 2. And parameter 2 is the palette in the PPU into which the parameter 1's palette is loaded. If bit 7 is 1, then use the sprite palettes. So let's take a look at that. I mean, it's not doing what it's supposed to, but at the same point, I don't see anything obviously wrong with the code. So param2 is 8.1, so it would be not equal because that bit is set, which is what I want it to do. And then loads param1, ends it with 7F. What is 7F in binary? I'm too lazy to figure that out. Okay, that's kind of what I thought. Okay, so just that one. So, oh, right. So we're just clearing out that bit. So now we have just the value of 1. Why is it doing that for parameter 1? The palette to load the palette in the PPU into which parameter 1's palette is loaded. Okay. But load a palette high, address param1. Okay. It loads that. Param2. Oh, okay. It does do that. It compares it. And it branch carry set. It's not set because all right, so multiply by 4 to index into the palette. Right, because it's the sprite one. So, and then it stores that into the parameter, and it makes it sprite palette 5. And then load that and store that, and then load that, clear carry, add carry parameter 5. Oh, but that... But that should be multiplied. Multiply by 4 to index into the palette memory. Well, that is multiplied there. But that's not enough for here. Param2 is just 5. It was 1, and then we've got 4, and it should be 16. Because it should be multiplied again after that. If we didn't skip this part, right? So this has been a latent bug since the beginning, apparently. So this is the work to load the palettes into the game. And are the correct palettes being... Yes, so the correct palettes are being generated at this point. Partially, we're hard-coding those palettes in... excuse me, into the map file, and we'll worry about loading that later. But the issue is that it's overwriting the palette right now. So if we're not doing a sprite palette, we load parameter 1, and then jump to set PPU memory. Right, so there's no multiply that happens here. No, there is a multiply that happens here. So why is it not doing... It should be doing a multiply. Should be doing a multiply for the sprite memory palette here. Like what it should be doing... is at this point we should be saying load A, param2, and this to clear out any nonsense that is related to that high bit that tells us the sprite palette, and then shift left twice, and then store that into param2, and then it's going to get multiplied again, which is what we want. But I guess then we don't need... I can leave that alone because that doesn't hurt anything to do the check again. I mean, it's not necessary, but... Alright, so that might fix the problem. Okay. That should fix the problem of the wrong palettes being loaded in. Okay. So let's take a look at the PPU now. Okay, cool. That is... Is that right? That looks right. Color-wise, right? That is 0C. That color is 0C. That's 29. That's correct. And then that is... that part is not... Why? Hello? How is that possible? It's like it works and then something screws it up. The ship looks pretty cool that way, actually. It also looks like we have some data offset issues, which we can fix in a minute. Let's go back to our good friend, the debugger. And we'll do the same thing as last time. We'll look at what the palette looks like as we... go into loading the level. So we are here, Put a breakpoint there. What is that? You can keep going. All right, so we've got the first palette should be, or first color. And that's 1, 2, right? Yes, okay. So I assume it's something with the sprites again. Yeah, that all looks fine. Yeah, why did you mess with that? I can rewind, can I, in this debugger? I really love that feature. Oh, except when I mess it up like that. Okay. Let's step into this call here and see what we're actually getting. So it's a sprite palette, so we're gonna load parameter 1 and transfer it over to X so that we can get the right palette address in the ROM. Then we load that and we are going to, oh, it's 0. Why is it 0? Because it's the first palette. So it should just be offset by 16. And then yeah, so this is that's so weird that this was broken like this. So it's actually not so much that I want to even shift. I'm saying put it into palette 0, but I got to shift that by 16. And then, all right, so we will I mean, it's easy enough to deal with, I suppose. It's just annoying. So I don't even want to do this. This is nonsense. What I really want to do is I want to create a... Oh. Well, that's even better. I have these addresses that I can just increment, right? So I've got it in A already. Clear carry, add carry, 16. Branch with carry is clear. It's the same old stuff that we just did here. Increment, adder, param1 plus 1, store A into adder param1. Cool. Let's put a little note here. Offset the address parameter by 1, by 16, because this should populate the sprite palette. Okay, so now we should be in good shape for it not clobbering our background memory palette. This is why having some real art and kind of having an idea of what you're doing helps, because it helps you suss these things out. Let's go to the debugger. I want to just confirm that the first load of the sprite palette does not mess up our lovely background palette that we've gone to so much trouble to load. So open up the PPU, and there's our good palette for the background that we expect. And oh, I can't bring up the window. Yeah, so that looks like it messed it up still. Right? debug, step back. Debug, step back. Huh. I actually can't tell. No, it definitely changed it. Why? Come on, man. What is going on here? So that's that. That's the low. Add a param. Oh, because... dumb. Because this address is meaningless to where we are loading it in the PPU. So it was stupid. For any of you watching this and going, why is he changing this? Because it was a dumb mistake. That's why. So what I want to affect is this. And param2 is the offset into that. Maybe what I do, you know what? Yeah, let's do this. I should just add 4. Param2. Maybe that was the easiest solution all along. Clear carry, add 4. Tell it to skip the first 4. Store a param2. That's probably the best solution, and then it just multiplies it out the way it should have. I don't know why I didn't do that in the first place. All right. You come here, open that. Switch to code mode, please. Load level. Where are you? There's the breakpoint. It's still valid. Okay, let's take a look at our palette. The background palette looks good. Sprite palette was the only thing that was changed there. Good. Okay, that's all looking good. So now, all right, cool. That is, okay, so now the problem we have is there's some sort of offset issue. My guess is that we're not offsetting the tile memory properly based on something. ROMEM, let's see. What did we add that we didn't adjust the ROMEM for properly? We can even see what address it's pointing to when we actually get to that part of the code. So let's reset. All right, so ROMEM is pointing to the address 99F3. So if we open up the memory viewer and go to 99F3, that is the beginning of this lookup, which is not correct. So we have failed to increment the row memory in a few ways, which is fine. That's kind of what I expected because everything just looked a little bit offset. So we looped through, we did our 16 increment, and then we, let's see, increment Y, compare, that's the Sprite palette loop. So then load A0, store A, Load a max. Oh, okay. And then we recompute. Load a max rows. Okay, so I see where the problem is here, which is that row mem is not pointing. Wow, why? Okay, row mem, and then level mem. Okay, so level mem is being set. I'm pretty sure this is the... Yeah, okay. Yes, that's why. Let's add some further notes, because this is used later to reset the pointer into the actual map data. Okay, so this is not going to work 100% as is, because it's not just the 15, it's not just the 0E, or sorry, 14 that there was. We have to increment that value to offset for some of the variable things we have now, right? So we have, let's see, level mem, where does that set row mem? Level mem, so that's here at the beginning, at the very beginning. And do we increment anything beyond that? No, we just, all right, cool. So that's fine. So it's 1, and then it's the size of the lookup, which we don't know what it is yet, but we will. And we'll store that in temp. Before we do anything with that, we want to load a level mem, clear carry, add carry, temp. We want to add this, we actually want to add that +1. Add the variable length lookup to the level memory offset. Because, let's see, so there's that lookup, and then there's the lookup for, so 1, 2, 3, 4, 5. Then there's 16 bytes, which that part is going to be fixed. We can actually adjust that later. Then there's another 4 there, and then there's this lookup, which is another 5 things, and then we actually have the memory, the actual level memory. So we have to do a couple of adjustments, but as far as fixed data goes, there's just, let's see, there's 16 bytes plus 4 for the Sprite palettes. What is that? 16 plus 4, that's 20. And then the 2 adjustable amounts. So that 0E is really 14 now. And then add this. Let's just do this increment temp. This is, I feel like this is a lot less work. We're just basically going to add the 1 to it that we need to, and then where do we do our lookup? Where do we skip the part for the lookup? Or are we even? We may not have even implement. Oh, there it is. Okay. Load a that, store a lookup count. Yeah, increment y, blah, blah, blah. Store load M2, load a max row set, carry, subtract. Okay, so we're here. Transfer Y to A. Skip it, but like row mem is that because row mem has already been reset there? Return subroutine. Oh, that's if we're not doing a full screen. All right, where did I see where it was resetting row mem? Here, that's where it was resetting row mem. And then where is it getting? It's using level mem. Oh, but that's not. Story lookup. Increment Y, transfer Y to A. Add Y to the row mem. But row mem doesn't begin. That would get reset over here, back here, wouldn't it? Load full screen, that it's called where? Why can't I see? There. Okay, so we only reset that here. That's fine. So then if that's in the beginning, which is what we want, we're clearing out the lookup. So row mem would have, okay, this is fine, I think. And then, oh, so it's not using level mem here. So that actually isn't even, that's only using that. It's only using that when we're adding a row by row. So I may have to step through this because I mean, I think this is basically right, but the other issue is that the row mem stuff is, this is what we just added, right? Yeah. The row mem stuff is not 100% clear to me at the moment, how these map to one another. So let's build this and let's step through. And take a look. Because level memory should be pointing, I believe, at the last place in memory where we would have the data, if I remember correctly, so that we can just always points to the beginning of the level data, right? So we obviously want that to actually point to the beginning of the level data, which it obviously isn't right now. The changes we made should fix some of that. But if we like come into here, level mem is 9A05. Which is close. We're off by this lookup, which is 1, 2, 3, 4, 5 items in it. And then there is our actual beginning of the level data. But we don't have that being populated because we did not get that far yet. And that is variable. So let's see here. Get the lookup count. Let's be more clear about what lookup count this is. This is the palette. No, wait. What is it? It is the attribute. Get the attribute metatile lookup count. Okay. So we add that to level mem, and then we come through here and we do this palette loop, and we do our sprite palette loop. And then we are at a point where we are doing the load full screen. It feels like we should have done, I guess this is okay. Add carry. So this is where we should be updating. Yeah, this is where we should be fixing the way this is working for the level memory. Okay, so we do this, we get the lookup count, right? This is our lookup count, and this is specifically the metatile mapping lookup count, which may or may not be necessary moving forward, but we have that lookup count now. So what we want to do is we want to increment lookup count. Same thing we did before. Clear carry. No. Load a level mem. Clear carry. Add carry. Lookup count. Branch carry clear. Increment level mem +1. This. Store a level mem decrement lookup count. Now, let me just double check that I actually did that store in both places. I think I did. Yeah, okay. Load a clear carry mem. This is if we're just doing one row. This is for the full screen load, which is what we're concerned with right now. That's good. And then we decrement the lookup count, and then we, after getting the address of the lookup data, skip it, right? Clear carry, add carry, transfer Y to A, and then Y will have the offset that we want into the actual row data. I think we may have fixed that now. So let's restart that. Bring up all the tools we want. There's our source, and I believe the breakpoint will be there still. It is. Okay, so except store A. Okay, yeah, level mem is 9A1F. 9A1F. Oh. No, why? Oh, we're not there yet. We're not 100% there. I was so disappointed, but yeah, we're not. We didn't quite get there yet. Okay, this is where. That's where I thought we were. So if we step through here, now level mem is 9A18. 9A18, which is still wrong. Why is it still wrong? Lookup count is 3. No. Okay, that's why. So that's wrong because should it not have decremented? It should not have decremented this y value here. Man, PPU debugger. PPU debugger. Debugger. Come on. Source code. Okay. So that's the first breakpoint, but that's not the one I was interested in. I was interested in this one. That's gone now. Increment lookup count. Blah, 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 blah. Lookup count is... why is that? Wait, that's still wrong? What gives? Level mem is 9818. We're so close. That's where we want to be. That's where we are. Why was the value 4 for the lookup count? Tell me. Tell me. So it loaded 4. Row mem is at 9A10, which is at the beginning of this, and y is at 9, which is here. That's not even close to right. How did it get that far off? Okay, so y is at 8, and row mem is at 9A10, which gets us here. Why? Why is it there when we go to load full screen? Is it because of this palette loop? Increment y. Yeah, okay, because, right, because branch not equal, sprite palette loop, load a param 3, branch if equal to load full screen. So the problem is that we loaded the sprite palette loop 1, 2, 3, 4, and we never incremented. We either have to increment y to the appropriate location, or we just add 4 to row mem. Increment y, transfer y to a, and y is 8, so y is too far into... How did that happen? Is it because in this loop y is... I hear the dog. Who knows what he wants? Alright, so row mem is... He probably wants food, because that's what all dogs want all the time, it seems. That is the right location. So y is y. Oh, it's looping through... Whoa, it's looping through 8 times, but we're only loading the sprite. Okay, this is making a little more sense now. We're looping through 8 times, but that should be 4 times. Because I guess we were loading the palettes... Yeah, I guess we were loading the palettes... Oh, right, we were loading... Okay, I remember why now. Because we were loading 4 palettes... sorry. We were loading 8 palettes, because we were loading the background palettes and then the sprite palettes, but we're no longer doing that. We're just loading the sprite palettes there separately. And that is the cause of this last little bit of it being off. I believe. Of course, I said that before too. So don't take my word at face value. Let's take a look and actually see. All right, we hit a breakpoint. We were checking against 4. We don't need this breakpoint. We want that breakpoint. Well, actually, we want this breakpoint. So we're going to load full screen, and Y is now 5. And A is 15. All right. So load a row mem. That's not right. Okay. It's closer. It's close. We're getting there. All right. So increment Y. Row mem is 9A10, which is what I expected it to be. And Y is 5. Y is 5. 9A10. And so that would put us here. So Y is 1 too many. And I guess it's 1 too many because why? Did we increment Y? 1 extra time. Compare against that. If it's not equal, then do this. Then we do a branch of to load screen, load A, 0, store A. Oh yeah, we increment Y here unnecessarily. Not here. Here. Okay. And that should be the address we're interested in. And we're going to hit our breakpoint, transfer Y to A, which is 4, and we're going to add that to the row memory. And that'll be our lookup value. And load a row mem. So row mem is 9A0F now. 9A0F. 9A0F. And then Y is 5, which gets us this value of 5. Okay. So now we have our lookup count correctly. And then we're going to increment level mem by that amount. Level mem now points to 9A18. 9A18, which is sadly still off by 1. Metatile lookup count. So it's because, probably because row mem was, yeah, row mem was this location. And then we had this as 5 bytes. And then our lookup was 5, so why was Y? All right, so should we just increment it by 1 just to, because the issue is that row level mem is off by 1 because of, well, that's off by 1, but I guess it shouldn't be that, it shouldn't be off in that way. Let's see. Coming into it here, level mem is 9A12, which puts us squarely at the end of the palette data and into the Sprite palette. So that's actually interesting because I would expect it to be here. If we go back for a second, maybe the base offset is wrong where we add the 20 to it, the 1.4 hex. That could be our issue. Maybe I miscounted. So level mem. Oh, really? Well, there you go. So 9A0C. That is starting, excuse me. That's like right in the middle of this palette data. What was it beforehand? It is 9AF8. You can see that it's a good thing that we did what we did, because we did hit the boundary and it did have a problem. 99F8. That is the beginning of the level, literally right at the beginning. And so let's see. So it's too early to tell if that was the correct amount, because now we're at 9A0C. 9A0C puts us here 1, 2, 3, 4, 5. Yeah, that's still, it should be over here. It should put us. So 1, 2, 3, 4, 5, 6. I'm off by 6 bytes. Let's see if we can account for those. I don't like just adding arbitrary values and finding out, not knowing exactly why. So there's one. Oh no, that, okay, yeah. Yeah, okay, because it's the count and then 5. 1, 2, 3, 4, 5. But we're still now off by 1. So this is 1 byte. And then we have 6 bytes here, but we're going to ignore that because those are arbitrary. 3, 4, 5, okay. And then we have 16 after that, right? So that's 17. And then plus 4 more, that's 21. So yeah, so okay, so my math was wrong there. And I don't know how they did this without debugging tools. I imagine they must have had some sort of debugging tools at some point. Either that or they were way more patient about working through their code, because it also probably took a lot longer to compile. And so you really looked at your code very carefully. I know I remember talking to people where it was like to compile, you know, whatever they were working on in C or something like that, you know, it'd be half an hour. So you'd make sure it was good and you'd hit compile and you'd go get coffee and hope you didn't come back to errors where it was just sitting there waiting for you. Okay, so now I think we're actually maybe gonna actually hit what we're supposed to. All right, we've got our palettes loaded and we're at load full screen, and level mem is 9A13. Yes, okay, that looks more like what I was expecting because it's right at the beginning of this lookup. And the lookup count is 5, and so we're going to add the 6 bytes to level. So now we're at 9A19, and that is the beginning of the level, ladies and gentlemen. So that is exciting. So now we should have a map that is incorrectly colored. No, it's still. Why is this? Get out of here. How? It's still offset. Okay, so ROMEM now is probably wrong. Let's take a look at that. Right, because ROMEM is now, that has to match up. If that doesn't match up, then we know where the problem is. So that's 9A0F. And that, now we're going to add the lookup count, excuse me, to that. Well, 9A0F, well, that's not, that, oh, plus Y, yeah, so that's 5, that's going to be 5. We're store that, and then we're going to increment that. Okay, we're back where we were before. Transfer Y to A. And Y was unmodified, so that's fine. Clear carry, add the lookup count, and that puts us at 10. And transfer that back to Y. Now ROMEM is at 9A0F. 9A0F. And then we are take the max rows and subtract 15, but ROMEM is not at the beginning of, that's the problem. ROMEM is not at the beginning of where we want it to be. ROMEM plus Y, let's take a look here. ROMEM plus Y, 9A0F plus A. Is 9A19, which I believe is the level mem also. Yeah, so that is the address we want it to be at. For some reason, it is not. But, I mean, realistically, what are we doing here with this? Do we use this anywhere else? The Y value? We do, but we actually clobber it, so this is useless. So this add carry lookup count, I know what I was trying to do, but realistically we should just load a level mem, store a ROMEM, right? Because that's what we wanted to have in there. We wanted to have that data, or that address. I mean, it is data, but that specifically the address is what we care about. This does not seem correct still. Why? Why? So ROMEM is 9A1C. Whoa, 9A1C. What did? Oh, maybe something in the ROM changed. Okay, yeah, that is the right location. So All right, so load A0, store A into temp2, load the max rows, which is correct, and then set carry and subtract. And then we're doing a 16-bit shift multiply, store that into temp, and then load row memory, clear, and add the temp. And then store that, and then if the carry is clear, skip that. So that puts us at what? Row mem is 9ABC, 9ABC, which is over there somewhere. I'm not sure exactly where that puts us in the level. And carry row mem, store, skip row mem increment. Done with row mem, seek into ROM. So row mem is now at 9FBC, which is, yeah, that's like close to the bottom of the level. So, okay, that actually all looks sort of right. I guess the question then becomes, is it because the palette is wrong and random? We can look at the tiles to determine better what's going on here. All right, let's look at our tile. Those, yeah, those tiles look. Where are we? Oh, we're looking at the title screen. Okay. Okay, let's take a look at these tiles. Are these actually different, or is it that the attributes are? Those are zeros. Those are actual tiles. There are some that look like they could be close to right, but there are others that are not. I thought we had it working pretty well. Or it showed part of the map at one point, so I was hopeful that we were in a position where it was working. Got the actual metatile value. Is the lookup bogus? Like, what does lookup have in it? 9A16. Oh, it is. Wait, really? So it is pointing to the beginning, which includes the count here. So that could be part of it. Load A row M, start ball. Transfer Y to A, clear. Oh, that was why we were incrementing Y by 1. That's got to be why, because we know we want to skip the byte. But the problem is then that was messing things up. So if we increment Y here, and then we have lookup, and then what we want to do is we want to decrement Y, because we actually need to get that lookup count. All right. Let's see if that... Let's see if any of that actually was right. Oh, I ran out of seltzer. I just kind of want to go for it and see what this looks like here. Okay. It's still not 100% right, but this is a lot better. If we resize the window appropriately, we should see some of the wavelets populating, I think. Yeah, there's one. Let's go to the actual map and look at this for a second. But it looks like we're close. It looks like we're really close because it looks like it's just shifted by maybe a metatile or two. Yeah, it looks like we're off by two metatiles here. And if we can figure out why, we can fix it. So the question now becomes, how did we get off by two there? Load a level mem, store a level. Okay, so is it because are we doing something in here where we expect to be off by two? Like, where do we actually, so we read the row mem here, load y0, and then we do the lookup here. That's weird. Let's take a look at that code where it's actually load, no, not you. Load level. Is there something more specific I can look up here? Load tile levels, get the normalized metatile value, and then do the lookup. Okay, so just load tiles should do it. Load tiles. So let's take a look at or too late. Okay. So row mem is pointing to 9fcc. 9fcc, which is in here. Should 9fcc and y is what? Y is 0 coming into this? Oh no, it's not. Well, yeah, it is. Okay. So it loads a 1 and then transfer A to X, transfer Y to A, push A, transfer A to Y, transfer X to A, transfer A to Y, and then do the lookup, and it's the same thing, and then shift it, and then store it into temp and pull and transfer, and so load metatiles that, and then that. Okay, that seems right. It just seems like somehow the math that we're doing to get to the location we need to is somehow off. And that is calculated here. So max rows is 69 in hex, which I believe that's just what we have stored in here. Yeah, that's 105 rows. So then we're going to subtract 15 from it, right? 5a. So then we're going to do our 16-bit multiply. Take max rows and subtract 15. Multiply by 16 the number of metatiles in a row. Please tell me that that's correct, that I didn't somehow mess that up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. Okay, so ASL, rotate left, ASL. So, so temp2 has a 5 in it, and so it's 5A0. So temp has the A0 and temp2 has the 5. So 5A0 is that number seems right anyway. 1440. That's 105 times 16. 105 times 16. 1680. But that's, oh, right. It's 105 minus 16 times 16. 14. Really? 105 minus 15 times 16. I did minus, okay. I did minus 16. So that, all right, that's fine. We subtracted our 15 rows from the end and then did our multiplication. And now we have row mem, which is 9A1E. Which is the beginning of the map. So we're going to clear. And this is A0. Okay, so we're going to clear carry, and we're going to add carry. Carry is not set. So now we stored that. And then because carry is clear, we skip that. And then we're going to load temp2, which is 5. We're going to clear carry. Row mem plus 1 is 9A. So temp is 5. So we're going to add to that. And we'll restore that. So that puts us at, where's row mem? 9FBE. 9FBE. Okay, and then add 8 bytes and minus 4 bytes for, okay, here we go. This is the problem. That is the problem. So we offset it later doing that math, but we don't need to do that anymore because we already had the right value coming in. Position in it. So let's get rid of this. Oh, I see. And we were adding the lookup count here, which doesn't need to be. So all of that is not necessary anymore because basically we have level mem set correctly, and that will take care of it when we just force everything to point to the beginning of the level with level mem like that. Shooter.nes. So now I think we'll have, okay, that is what we wanted. So now, okay, so for next stream. So here is the part that I made the note about. So we have a value in temp, right? Temp is the metatile. And what we need to do is we need to look up the attribute for the metatile. We don't want to use the attribute value for the metatile. We don't want to use the value of the metatile itself like we're doing here. So what we want to do is we want to load A with, well, A is already has temp. I don't actually know if we have to store it there. Or is this where we are? Just bear with me a second, because shift left, blah, blah, blah. Oh yeah, we do need that. Okay. But we want to do this actually before. So what we really want to do is we have this value in A. We want to transfer A to Y, and then we want to load A with attribute, mtattr lookup Y. That's going to give us our proper value. We're going to store that into temp. We already have that. That should be the lookup that we need. I don't think we care about Y here. Do we? Load X. Do we care about this? Do we care about Y at all in here? I mean, I load Metatiles Y. Transfer A to Y. I just want to make sure that the Y value is not going to be a problem for the loop. I think it's okay. We'll know in a moment. Because it'll either look right or it'll be totally messed up. I'm hoping it'll be right. And we can end with things looking right. Okay, that doesn't seem to have actually done anything. Load new tile row. Temp hazard base offset. Transfer A to Y, load A. Let's take a look at this code. Right, so this is our code here. I don't need this breakpoint anymore. Those are all looking good. Oh, is it? It's not calling that code? Wait, what? Did I disable it by accident? Why is it not? Oh no. Why is it not? Populate single tile. How is it not calling this? It's loading the map. So what gives? Proceed with map render. Yeah, it's not a repeat scroll mode, right? Process map mode. Okay. Checking for objects, done with objects. Load camera position, initialize sprites. What is this? It's checking the controller position. Oh, it didn't. Okay, it said it didn't need to load stuff. So subtract carry 1. Does it not call this part of the code? Load new tile row. Jump process map mode. Okay, is this old code? It could be. Increment scroll counter. Yeah, that's definitely called. Skip scroll process. How? check objects. Compare X to level object count. Done with object. Branch of equal to done with objects. Oh. Okay. That's fine. There is, yeah, there's no objects. Done with objects. So now, oh. Wait, what was that all about? Load a scroll counter. Yeah, okay. Increment subrow. So where does it process the attributes? Load new row. Next metatile. Load a row mem. Store a temp. Load the metatile value from the map. Multiply by 4 to the offset the number of tiles per metatile. Where is it updating the attribute buffer? It's doing it here. Load, pull the current value. Okay, so I was updating old code, I guess. That gets stored into temp. Metatile flag, skip inline add. Okay, load a temp branch of equal. Otherwise, subtract and then store that into temp. Transfer Y to A, and it with 1. Transfer A to X, load it, and store that in the temp word. Load tile counter. Save the masked value. Load a temp word. Load the left 2 bits. Store it into temp. Load a temp word plus 1. Load the right 2 and then shift. What is temp word? Load a temp and then store it into temp word X. I mean, that looks like our attribute thing that we were looking for. A is 0. Oh, it's actually 1 because that's the attribute. All right, so transfer Y to A, transfer X, load a temp and store it into temp word, which has a value of 0. All right, so really what I want to do is, I guess this part doesn't actually do anything. So we can get rid of that. I should probably check into why I kept that around, but okay. Skip inline attribute update. So this is the code that we're looking at here. It does the subtract 0 and then it does the store. But what I really want to do is I want to transfer A to Y. Although I need... Do I need Y? I do need Y. Okay, so store it. Transfer Y to A. No. Push A. Load a temp. Transfer Y to A. Transfer A to Y. Load A with empty adder, lookup Y, and then store that into temp. And then from there, I need to pull A and transfer A back to Y. And then I don't need to do this because it's already in there. And then, okay, let's see if that... Because now we have the right tiles, at least. So that's good. But the attribute lookup wasn't doing what it was supposed to be because that code wasn't actually accessed. So, oh, you know what the other thing is? We're not using that lookup for the tiles in that full screen, but that is right. That is totally right, which means that it's when it's loading the tiles. Okay, that is exciting. Okay, so when it's loading the tiles, it's loading them correctly. Where is the attribute buffer? If attribute mode is 0, we're storing least significant. Okay, so this is actually similar code to this. So what we need to do is transfer Y to A and push A. Actually, we got to store this first. Transfer Y to A, push A, load A with empty attribute lookup Y. Load Y temp. Actually, I just realized something. I could have done this. I didn't need to do that one extra opcode. And then store. Okay, cool. So then store that into temp. And then pull A and transfer A to Y. And, oh, we got to do... What is this doing? Is this doing this multiple times? Did I unroll? Why is it doing this so many times? It's doing it 1, 2, 3, 4 times. Okay. I guess I unrolled the loop so it would load faster. Except that this needs to all right. Romem Y, increment Y. Do I really need to do it this way? ASL, ASL, ASL. Oh, because of the shifts. Yes, I do. Increment Y, and then load that, and then do the same thing. Okay. So, how do I do this in a way that's not totally dumb like this? Hey, Yamato Special, how's it going? Doing the attribute lookup. And storing that into temp. But then it needs to OR that here after doing 2 shifts. So the value gets shifted. So what I really want to do is like do this, because I don't think I need temp2 in here, right? Let's see it referenced anywhere. Okay. Oh, I do it more than that, don't I? Oh no, I don't. Okay, thank goodness. All right. That's the last time I do it, hopefully. Yeah, okay. Been studying for interviews, have to take a break from NES Dev. How are you, man? I'm good. I'm good. We're getting somewhere. We got the tile data is loading correctly, and the attributes are loading correctly, so that the palettes look good when the scrolling is happening. But this initial load, the attributes are wrong, so the colors are off. So we're really close, because you'll see when it pops in, that's correct. So I need to just implement this lookup here to do what I need to do this looking up. This is so ugly though. We're using X for anything in here? I don't know if we are. Maybe I can use X. No, we're using X for the attribute buffer itself. Okay. So, yeah, it's just going to be ugly. Because of only 2 index registers. Okay. So we're going to store this into temp2. Haha, yeah. Wrong kind of ASL. Arithmetic shift left. So store temp2. And usually it was written, you know, I mean, depends. Sometimes it was just ASL, no punctuation. All right, so we're storing that in temp2, and then we want to basically look this up. So we want to do the same thing now here with temp2. I think this, actually, you know what? Let's do this like that. Because what'll happen is that I think this will scale for all of these, where we store into temp2, transfer y to a, push a, load y with temp2, we do our lookup, and then we store it into, no, then we can't store that into temp. We have to store that into temp2. And then we OR that, and then we store that. Store load A with that. Actually, too many moving parts here. So the first one we load, we store it into temp2. We get the right value for it, and we store it into temp. It's cool. Glad to hear you are making progress. I'm so tired. I do 10-hour days now at work, so I can get every Friday off. And today was very busy. Yeah, it's I can't believe it's midnight already. I just really want to get this going. How are your recruiting calls going? So temp2. All right, so that's got the right value in it, and then, or that doesn't have the right value. That has close to the right value. That is our lookup value, and then we get it and we store it into temp. So temp has the first part of what we need. And then we increment y. You load the value. We subtract it. We store it into temp2 because we have to do our lookup for it. So we transfer blah, blah, blah. We look it up. We get our correct value for it. Now we have y. We actually don't. Let's see. We don't want to do this yet. Store a into temp2. We actually don't need to do that. What we need to do is this. Right? Yeah. And then pull a, transfer a to y. And then we don't need to do this y back to a because they're already there. And then we add, and then transfer a to y. And then we have this thing where we look it up and then we store it into temp2. And then it's the same nonsense here. Transfer y to a, push a, load y with temp2, load a with empty attribute lookup y, store that into temp2, right? Oh, well, not yet. I guess we want to, we have the right value now. So now we're going to shift it 4 times and we're going to store, do we need to store that? Load y temp2. Now, we don't really need to do that. We shift it, we OR it against temp, and then we store it, and then we need to pull A and transfer A to Y, and then we increment Y. Then we load this, and then we want to store that into temp2 and transfer Y to A and push A, and then load Y temp2 and load A with empty attribute lookup Y. So we're just going through this mechanically of just, you know, finding these values, and then we're doing our shifts, and then we're ORing it, and then we're, oh, and then this is the last one where we actually just store the thing off into the attribute buffer. I got all of them, really? Let's make sure. Load the value with Y. We stored it to temp2. Y to A, push A, load Y with temp2, load the actual value into A, store that into temp, pull A, transfer A to Y, increment Y. Load A with that value, branch if equal, so if it's 0, we're going to subtract the value. That's all good. We're going to store that into temp2. We're going to transfer Y to A and push it. And then we're going to load Y with the value, and we're going to load A with the looked up value, and then we're going to shift it twice, and then we're going to OR temp, which had this value that we just manipulated there, and then we're going to store that because we need it for later, and then we're going to pull, and we're going to transfer A, and we're going to clear, and we're going to add, and then we're going to transfer that to Y. So that seems okay up to there so far. That was this one. So then we're going to load this, and then we're going to store it into temp2. We're going to transfer Y to A and push it so that we don't clobber it. We're going to load Y with temp2. We're going to do the lookup, and then we're going to shift it 4 times. And then we're going to OR that against temp and store it. And then we're going to get our Y back and increment it, and then get the last value that we have to do this for. Transfer Y to A, push A, load Y, load A, shift 6 times, OR it, and then put that into the attribute buffer. I think that is right. They're going well. I did a coding take-home assessment from a place called Medium. I'm interviewing at Zoom, Google, Facebook, and Dialpad. Okay, that's quite the list of places. So that's good. Branch of equal. I hate having to do this. So okay, so if it was not equal, we were going to this. Otherwise, so we're branching if equal, skipping. And otherwise we're jumping there, so that should fix that. All right, let's read. Yeah, interviewing is very tiring. I guess it's better given that you don't have to go anywhere, hopefully. Invalid opcode. Well, that's interesting. Not sure how I managed that. Back when I was interviewing for my current place, that was the interviews before the pandemic hit. Constantly traveling to have to go into places, and it was very tiring. Is the stack busted? The stack is busted. Okay. Well, see, that's what happened. It was the stack. So the question is, oh, I know what I did wrong. Stored it into the buffer here, but guess what I didn't do? I didn't do a pull A and transfer A to Y, which is a problem because that means we didn't, not only was Y wrong, but we also had a Stack Overflow. Okay. At least that makes sense. Hey, hey. Look at that. So the colors, let's take a look at the colors that are in the palettes here. So that's the, why is the lookup for, did I use, that is the right palette. What is the attribute value? This looks right, but the surrounding color is not. Yeah, no, the studying is difficult, but well, good luck, man. I mean, hopefully it pays off. Let's take a look at this. What is the attribute? I haven't really disclosed much of the storyline of the game yet, so right now I'm just trying to get this working. What is, like, these are the right tiles, right? And it's not somehow consolidating that. See, now this is cool because this is potentially like an issue with the way we were consolidating the metatiles, right? So for attribute, so for metatiles 0, 1, and 2, they're all the same palette. And then for metatiles 3 and 4, we have those palettes. So let's look at our level data. And we have 3 here and 4 here. So that looks correct in that we should be getting this palette value. But it doesn't appear to be updating. Oh, thanks. Yeah, it actually loaded. It's the green color here in the background is not correct, but everything else is right. It's kind of weird actually that it is, so 4 worked, but 3 is wrong. I wonder if that's because the metatiles are, oh yeah, okay. So that subtract is actually hurting the lookup. So like if we do 3, that gets turned into 2, and then we look up using 2, and 2 is 0, 1, 2, which is that palette. So it just happens to work for the last one because it's offset into that. So all right, cool. At least I know why. So how, this shouldn't be hard to fix. Load Y and then increment Y. I think that's all we need to do because we know, no, wait, this here, because we know it was subtracted from, and we know that that is bogus for what we're trying to do here with the attributes. And then we got to fix that in the scrolling code, and I think we have a working solution. So yeah, Yamato Special, I haven't talked about the story yet. I will disclose some more as we work on, hey, there it is. I will disclose some more as we start building some of these levels now, and tackling some of the technical hurdles that come with them. All right, so here's where we start doing some more interesting things. Let's incorporate one more thing into this. So projects a sprite. I may regret doing this instead of just leaving on a high note, but let's try. Let's do the roadway and do that. We know that that's a different palette. So let me grab these here, and we'll just do that, right? And then that is not visible, but we know that that is going to be not palette 1 or 2, but palette 3 because it is yet another set of tiles that we have not properly that we have not used before. Okay, so that's saved. Let's export. Oops. I don't know what it exported it as when I did that. Let's export this. Okay. The next thing we need to do is I need to look at the palette and update the hard-coded palette. So it's black, dark gray, light gray, and white. So let's go to Screen Tool and look at what that might actually look like. Palettes. You do a good job recognizing what's causing errors. Maybe it's just inexperience, but I spend all day figuring. Yeah, it's like that's where 20 years of programming experience pays off. It's like, you start to learn a rhythm to the problems, so that you're not struggling through them. Because, at the end of the day, a lot of these problems are similar to other problems that I've encountered. So it's just a matter of kind of correlating that in your brain. And, yeah, that's definitely just an experience thing. At least that's how I see it. So, all right, so that's 0E, and then what palette color is that? That's 0, and then that is 10, and then that is 30. So this is all, me hard coding this palette in because I just want this to work. All right, so it exported the map again. Let's go pull these files and let's rebuild the game with the new map stuff there. Let's see, it may complain about some sort of missing files. No? Okay, cool. Let's see. That's weird. Oh, no, it's not. I forgot that for whatever reason, Messin isn't reloading the way I wanted to. Okay. So that is success. The colors are wrong because the palette placement is wrong, but I would consider that a success. Oh, interesting. And then the palette lookup is, see, I wouldn't have known that had we not done this test. That's okay though. So let's do this. Let's take a look at the metatile that got generated. I believe this would probably be like 6. Nope. 7. That's the grass, or the forest, or whatever it is. 2. It's going to be somewhere. I thought it was going to be at the end, but here it is. So it should be. I have the wrong order. It's 10202D. 10202D. All right. So this will go away when we actually load. Oh, what's the matter? Oh, I have the tool open and you can't update it. This will go away when we have the palette actually getting loaded properly from the palette file, and it maps everything based on that palette file, and then I won't have to swap things around, and of course then I won't hard code the palette into the map. But this was all for purposes of testing this functionality. And there is a problem where it is kind of off. There it is. So that looks pretty good, but it is going to be off at the top here. It looks like it's using the wrong palette there, but let me think about that. Oh, you know why? I know why. Because we didn't correct. I'm pretty sure I said we have to correct this over here too, and I didn't. So there it is. That's that. That should fix it. I ended up in a minor in computer science, but I've never coded professionally. The majority of my knowledge and experience is just as a hobbyist level. Yeah, I mean, and there it is. Yeah, it definitely makes it more fun to some extent. But so I'll tell this story because this is actually a good spot to stop. This is actually working, which is fantastic. I went into computer science thinking I knew better than everybody else, because prior to going to college, I actually didn't want to go to college for computer science. I wanted to go to college for game development on the West Coast, and my parents said, hell no, you're not going to Washington State to go to some college we've never heard of. I mean, it's kind of past history, so there's really, I can't say whether it was the right decision or the wrong decision. It was just, that was the decision that was made. And I really didn't want to go for computer science because of thinking that I would actually learn anything from it. I went because it was like, well, this is obviously what I'm going to do. I'm going to code. That was what I was interested in. And I just wanted to get the degree so that it was like, okay, I have the degree, just hire me already. I had already worked as a junior programmer at a local office for a pretty big Japanese audio hardware company. When I was 17, I got a summer job there. Learned a lot. But you know, I was capable of doing what they needed. And that was part of the reason they hired me, was because they were hiring, they were looking to hire high school kids and, pay them no money in exchange for teaching them stuff. And then, just randomly through my high school math teacher, he asked if I was interested, and I'm like, somebody wants to pay me to code? Yes, please. So I interviewed with them, and actually I had been meaning or wanting to, hello pup. I had been kind of debating posting this on Twitter, but with everybody talking about minimum wage, and they offered, so they said, yes, they want me, to come programming there because I know C already and I know assembly language, and nobody they've interviewed from any of the high schools had the level of knowledge that I had at the, and it not like it was a ton of people interviewing. It was just, of the people they interviewed, I had what they were looking for, and they said, we'll pay you minimum wage, which I was thrilled about. And my mom was like, wait a minute, they're asking you to come in and write computer software. You can go work at the library or McDonald's or Burger King for minimum wage. which is, you know, like I had friends working at Burger King who kept, you know, who had mentioned I should go work with them there. She's like, you know, tell them that you can do other stuff during the summer that involves less time and less work for the same amount of money if that's all they're willing to offer. And so, you know, not really knowing any better, I did, because, you know, if nothing else, she had to drive me there to get to the job. So if she didn't approve, I wasn't gonna work there. So anyway, the point of the story is that I told them that, and they came back and they offered me. So minimum wage at the time was $5.25 an hour, and they came back and offered me $8.50 an hour, which seemed like a lot of money at the time. But it was kind of relevant to. I felt like that kept popping up in my mind every time. All those Twitter conversations were happening about minimum wage and how, you know, in my mind, really what it's about is it's like you then have to incentivize people to come work for you. I mean, and there are a lot of trade-offs. I'm not saying that setting a higher minimum wage solves the world's problems, because there's, I think, merit to both sides of the discussions about, you know, pro and against. I mean, ultimately, the big issue is obviously people need to make a minimum, make a living wage, and especially here in New York, that's hard. Things are really expensive. Our taxes are crazy. But all of that is to get to the point where I said, you know, I didn't want to do computer science. I was just doing it to get the degree and get a real job. But I actually learned a lot of the nuances around algorithms and how to think about computing and how to structure things in computing. And so, you know, I'm glad that I took that, and I'm glad that I did that stuff. But what it doesn't teach you, and this is my long-winded way of getting to this point, what it doesn't teach you, though, is the sort of mechanical parts of computer science, which are, you know, the dealing with large projects, dealing with structuring projects, dealing with debugging large pieces of code, dealing with debugging intricate pieces of code. All of that stuff is stuff that you learn how to do through experience. And so while hobbyist stuff is definitely fun, if you're not doing it full time, that's the part that you're kind of missing out on. Although I wouldn't say you necessarily are missing it, but, like, you know what I mean, right? Like there's a lot of just time in front of the keyboard, in front of the screen, that results in you learning how to do these things, and pulling from that knowledge, because, you know, eventually you learn to recognize something that looks like an off by one problem, no matter what it manifests itself as. So you look at the map and it's wrong, but you notice, like, hey, it's wrong in a very particular way, like it was skewed, right? And so it's like, why would it get skewed? It would get skewed if somehow you were reading in some extra data, which would shift the columns incorrectly, and that shifting of the columns would happen if you were off by a certain amount of, you know, might be off by one, might be off by a few bytes, and that was what we were trying to troubleshoot. And then also, you know, that's the intricate part of the game that we changed, right? So that was what we were changing the output of the export tool to adjust. So it's kind of logical that would be the place that is broken. What do you want, Charlie? The dog is sitting in the dark in the workshop crying. I don't know why. Maybe he's telling me he wants to go to sleep too. So anyway, I don't know if that made any sense or was useful to anybody, but that was kind of my, again, long-winded way of saying the computer science stuff teaches you a lot of really important fundamentals, but it's no replacement for just sitting and coding for a long time. But I'm very happy that this is loading, and loading correctly with the right palette. So now what we would need to do for the next stream is we have this entry here. I called it palette 1, but I think I'm just going to have one palette file that gets loaded into the properties. And we want to load that file, and then we want to use that for, in the asset tool, we have like I said, Arachnarenth. I hope that was actually, or I keep doing that. Arachnarenth. I hope that was actually helpful though, and not just me spinning my wheels and explaining something that was like super verbose for no reason. Yeah, so this load image palette, I believe it will, does it look at, I can't remember if it uses the existing palette or not. Why are you not highlighting palette destination for me? Final palette. Is it not used in here? It does a mem copy of it here. Okay, there's some function I have in here where it actually will index using an existing palette. Actually, it probably gets used right after this is called. Replace export palette. Convert to. So convert image to indexed, and then after it does that, there is a call. Why can't I find you? I mean, it's not critical to the discussion, to wrapping up right now, but I just want to see if I'm remembering that we have such a thing. Load image palette. All right, so load image palette is there. I could swear convert image to indexed. This does the load. Oh, you know where we probably do it? PNG to Sprite. I believe there is in this, if you convert the PNG, it can use an existing palette from a file. Convert image to index, load image palette. So if the sprite is passed in, that might be it. Yeah, okay, so that's where it is. So if the, right now it's doing it if you pass in what's called the initial sprite, but so what we can do is instead of calling load image palette, we can do index image tile potentially, and pass in the right palette and have it convert. I also feel somewhat overwhelmed by increased quality of NES homebrew. Sometimes I feel like I'm trying to reinvent the wheel. Yeah, no, I totally get that. I mean, you get a game like Micro Mages or Trophy or Twin Dragons or Project Blue, or but yeah, so all of those are phenomenal games. They look great, they play great. Lizard, I'm trying not to leave anybody out. NEScape, Swords and Ruins. There are so many of them that are around now that are really good. But honestly, it's just kind of like you got to do what you got to do for you. I mean, I look at Franken Graphics work, and she does amazing art, and it's kind of like, do I ever? Oh yeah, the Haunted series, exactly. Full Quiet looks amazing, and when I played it at MagFest a couple of years ago, it was great. I can't wait to actually get that one. But you look at her graphics, and you're just like, why do I even bother with making my game? Because I will never have graphics that good. And But, you know, you can't think like that, because that's like, then nothing ever gets done. So the dog is still crying, so I'm gonna wrap up for tonight, because otherwise he was gonna go upstairs and wake somebody up. So with that said, thank you everybody for watching. If you'd like to reach me on Twitter, I'm at Clairvis. If you want to reach me on Discord, you can reach me through the Video Game Sage Discord as Zelius. I'm on Discord as Clairvis. And you know, you can find me on Patreon or buy me a coffee. You can email me at zelius@gmail.com. And yeah, that's it. Thanks for watching. I'm glad we got this done. And in the next episode, we will keep going and get these palette things loading dynamically. And yeah. All right. Bye, everybody. Have a good one.